Yeah, so I'm excited to talk about Solara and how Solara can simplify building complex dashboards in Python. And as you see, I put an asterisk at dashboards because Solara is more like a general web framework, so you can build a web app in it. But most people, they start looking for like a dashboard solution, only to find out later that they want to build something like larger or sometimes described as a data app. But dashboard is kind of the common word people use. Okay, so let's introduce myself a bit. I started life as a software engineer, but then I, out of curiosity, went into astrophysics, did a PhD and postdoc there, and this is kind of how Dali sees me. So during my postdoc, I created two projects, one FEX, an out-of-core data frame, and my other work was on a IPy widget library, IPy volume. So these projects led me to become a freelancer in 2018, and especially the work on IPy widget and becoming an IPy widget maintainer led to me becoming distinguished contributor for Jupyter, and also my work on Voila added there. So I worked with passion also on Vex, but really the clients that we had, they drove me towards the dashboarding direction. There was a overwhelming need for that and a need to improve that. And that led to the company we have now, Widgety, co-founded with Mario and we're growing. So in this talk, I want to describe shortly why we built pure Python dashboards or web apps. I'll describe a bit of the problems that we saw and solved. I'll describe the solution to that. I always want to give a bit of a feeling how it works, so I'm going to do a live demo in between. And I think after that, it's I can better describe what Solara is. And I want to give a few concrete examples of apps built using Solara. So why do we actually build pure Python web dashboard? So web, I don't think I need to explain. Everything's web-based now. But why do we do it in Python? And it's kind of, it's really expensive to do separate like front-end and backend development. And actually the domain expert, for instance, a data scientist or a quant, usually knows Python, and they're actually the best to translate this into a dashboard. And also, it's very easy to access all the Python libraries that we use directly from Python instead of via an API, a REST API. So that makes for faster development and faster refactoring of the application instead of having to redesign your whole REST API. Also very important is team interchangeability. If someone gets sick and it's your front-end person, the project can still continue if everybody just needs to know Python. In summary, it's easier, faster, and cheaper to make pure Python web dashboards or apps. So what kind of problems did we actually see? So on the horizontal axis, we have the axis describing kind of your dashboard size. And we start often in the, on the left, a small app or small dashboard describing something simple. But they usually grow, and the dashboard grows in size, and it describes something complex. So there's some essential complexity in it, and that's fine. You're trying to automate or solve a complex problem or give insights into like a complex workflow. But on the y-axis, we have problems, or more formally, incidental or accidental complexity. That could be like your framework not really working in the way you want. And what we saw is with a lot of frameworks that once your app grows a little bit, that you have a lot of these problems, and you start feeling like this grumpy cat, not exactly happy, and basically dealing with problems you rather not deal with. So what we wanted is a solution that allows you to go further, like create a larger application without accumulating all these incidental or accidental complexity, and hopefully make you feel a bit more happier, like this cat. And we believe we've solved that using Solara, and that's what I want to talk to you today about. So what are the problems we observe? So I'll explicitly mention Voila and IPy widgets because that's what I developed on, but maybe you also recognize it in a different framework that you use. So I talked about this complexity, incidental complexity, and there are a few things why this happens. It could be that your state is spread in a UI, for instance, that the user is logged in is in a checkbox UI component, or it's in multiple components, so it's spread around. An imperative API, so you manually need to remove or add UI elements. And also event handlers, you have to remember like to detach an event handler, otherwise you still trigger some code. And together, you really need to keep the UI elements in sync with the kind of the state of your application, what it's describing, like the filtering, if you're logged in, etc. And all of this is basically is that makes it really hard to make your UI consistent with your state. Another thing we noticed a lot, which is a hard problem, is how do you in UIs make it possible to reuse code? Another thing I won't say much about that a little bit is, but if you're stuck in the framework you have, maybe your components are too limited of your framework, how do you get out of this? And all of this makes you feel like this cat, and we want to like solve that. On top of that, not being developer friendly, what we notice with IPyWidget, the development cycle is kind of slow. Restart your kernel, refresh your browser. That's not really something you want to be doing while developing. You want this cycle to be fast. Another thing we want, modern Python should have type checks. So that is something we really want to have and have a test framework. So how do we solve the complexity? So what we actually done is take a look at the JavaScript world, because they've gone through all of these problems, and they've built many UIs. So we've taken some inspiration from React and this particular signal for library from Preact, a React variant. But the main point is we think a UI framework should be declarative, reactive, have some encapsulation or components, and a story for state management. Hopefully, this will make you feel like this cat. So let's talk about reactive. You've probably used an Excel spreadsheet, or any other spreadsheet like in Google. You have two cells, width and length, and areas multiplication of these two. You change an element and everything updates. You don't have to manually go through your spreadsheet to say this cell needs to be updated. And how does that translate into Python? Let's imagine you have a component that shows the first 20 rows of your data frame. Now imagine you can change it with a slide and you want to reset it. So we have an event handler that changes this max row value. But you cannot really observe that this value is changing. Unless you're James Powell, this is really not a feature that Python has. Instead, you can use a very Pythonic solution is to have a container around a value. In this case, we have a reactive variable max rows that you then write to using the property value and access using the property value. And with this, we can implement that our components are reactive. Declarative. So what is declarative? Tell what you want, not how to do it. For instance, we have an old kitchen, old situation. I want the kitchen to look like this. I say a builder like, make it look like this. I don't describe like first put in the lights, then do the floor, then I'm not interested in that. I want this solution. So how do you do that in a UI? So in a UI, you want basically your UI to be a function of the data. So I already showed you these reactive variables. So let's imagine we have a list of messages. We can add a message, so we modify the reactive variable or reset it. Now we want to react to that. So if we don't have messages, we want to show something special, and otherwise we want to iterate over the messages and show the message. So what's happening here? Maybe this is already very intuitive to you, but what's actually happening is all the UI transitions in this particular example happen automatically. So you don't manually create the widget underneath it. You don't have to manually update it. You don't have to insert it. So if I add a message, it automatically inserts on the screen what's necessary, and you don't have to delete it. So if I reset and I reset the messages, it will remove all of the infos and replace it with the warning, um, so that you don't have to do as much work manually. Let's talk about reusability and encapsulation. Let's imagine we have this relatively simple code where we calculate the unique values, create a figure, add a bar plot, optionally set a title, and we show it. And this could be code that you're using a lot in your new dashboard. So you saw in the previous slides, okay, I apparently have to add this like a component decorator, function name, and give it arguments. Great. So now I can reuse this bar chart component in my application. But two things, like how is this like different from a function, and why this capitalization? Why is this not a snake case? So here I put another element in it, or making use of another component that depends on something else. Now, if this component re-executes, Solara will actually recognize that all the arguments are the same for bar chart. So it will not re-execute this function. It will actually see, okay, these are the same, so I'll reuse the previous one. And people love this a lot because, for instance, a comparison is Streamlit, which basically re-executes your whole script, while here we only re-execute the components where arguments have changed or internal state has changed. Okay, so we now evolve our app, give it an extra argument, so we can determine what the color of the bar chart is. But now imagine that we change the color. Now we re-execute this function while only the color is changing. And now I get back to why this is a case like this, as if it is a class instead of a function. And the reason is, if we re-execute a component, there's actually some memory of the previous execution. There's a lifetime associated to this function, kind of an implicit self, if you were talking about an object. And in this case, I'll demonstrate it using the use memo hook, which can hook into the life cycle of a component. And that is saying this function should only be re-executed when the data frame or column is being changed. And now it will only execute this function once if the data frame and column don't change. So this shows you like the power of components. So let's go a little bit further. You say, well, this is actually too slow. It's taking like 2 seconds for my value counts. So what next? This will block the UI. It's not really user friendly. And this for this we have this use thread hook. So that's basically another hook, and you see that the code change is really small, and this allows us to execute something in a thread, show the progress in a progress bar, and have the whole UI responsive. And this basically, this what's usually pretty complex working with threads is really encapsulated in this component. So a pretty complex solution is like fully encapsulated in this component and reused many times throughout your dashboards. So let's Hope my lucky slide works again. So I want to give you a little bit of a demo of how this works in practice. Okay. So we start the Solara server. Let's refresh it. Okay, it says no object with the name page. So what Solara wants is a component with the name page. Let's display my data frame. Okay. What I want to do is I want to take a look at this category. See if I can make some bar charts here. I don't like the casing here, so I help of Copilot turn this into title casing, and you see I save it and it automatically refreshes. So if I save it, the whole script gets executed. Now we want to filter by categories. Categories. We're gonna filter the data frame. Thank you, Copilot. I've filtered it to warrants only. So now we want to have a let's take this one. Copilot helps us again, so we have a nice label. The categories here. And you see that it takes this argument, so there's bidirectional communication. If the select changes, it updates the value. You can see that automatically re-renders. So very easy to set up. An example, I showed you this bar chart. So what we can do is already put this in a module. So we can have this bar chart with actually the threading. Now you see that we have a nice visualization. So you see it actually took a long time. I put a sleep statement in there. I prepared some other. Now we can show a map. Maybe we want to reorganize the app a bit. Put this in a sidebar. In 2 columns and not show the data frame. Okay. And now we have a app that can handle large data sets, can render maps, etc. So now you say, okay, my colleague is actually using a Jupyter notebook. Well, that's great because it's built on top of IPy widgets. So I can, in a classic notebook, Jupyter Lab, I can render this. Also on Colab, this works. So you can render it inline, then the sidebar shown here. I can make it render full screen. And what's nice is that I can now take a look at the reactive variables and say, well, actually, if I change it here, so I can read it off in the notebook, but also the other way around. So if I'm doing things in code, definitely trigger re-render from here. So you can have these like small mini apps that respond to changes in the data. Okay, let's go back to the talk. Okay, great, this worked. So what is Solara? You've seen a little bit of it. So we have 2 parts. So we have the Solara UI. You've seen most of that. It's a pure Python web framework to create apps or dashboards. It has a React-like API, so it's inspired on React, but also have reactive elements. And together with the declarative way of writing your app, this reduces complexity a lot. You don't have to think about like manually updating. And you can create these composable, reusable UI components. Having quite complex behavior, as I've shown, you can hook into the lifecycle, work with threads. But we also, because we're really data oriented, have a lot of components, buttons, sliders, but also for visualizing data frames. And as I said, we reuse the IPyWidget ecosystem. So there are a lot of third-party IPyWidget libraries that you can already integrate in your Solara app. But also solving common data challenges, threading, as I've demonstrated, cross-filtering, caching, etc. And we have a story for type-safe state management. So our reactive variables, everything's typed. That allows you to iterate much faster without introducing small bugs. And I didn't mention much about this, but we also have this Solara server. I'll go a bit into detail later. Let's describe a little bit how Solara is built. So on the UI part that you see here on top, that is built on top of a React-like API called Reacton, which sits on top of IPyWidget. So Solara is using Reacton and IPyWidget. And the nice components that you saw are coming from this third-party library IPyVutify, which is the material design. But you can also use these other IPyWidget libraries. As I've shown, it runs in the Jupyter Notebook, also runs on Lab or Voila, so basically on the whole Jupyter stack or Google Colab. But we also have this Solara server. It's using Starlet or Fast API. It can use Flask, use as a web server, still using the same Jupyter protocols. But this is something we recommend for production. It has an in-process virtual kernel. It's much more efficient for handling many users and sharing memory. So just to give you some examples of to get an idea how you can use Solara. So the Solara website itself is written in Solara, and it also has some larger demos. Here's a relatively simple but interesting example where you can upload the data sets, make a lasso selection, and then download the selections you've done. Demonstrate some of the very often requested features of uploading, downloading. A project started at Harvard that was using Qt, and that we're now using Solara to make this available on the web. A very complex way of interacting with data, multiple data sets. This is an example of where a prototype that was developed in the Jupyter Notebook for planning district heating and cooling is now turned into a full product that is the basis of a startup. We had a Solarathon, a hackathon that is just finished, and one of the groups produced a live dashboard. So these are updated live. And we got really inspired by the Wanderlust demo shown at the OpenAI Dev Day, and we made a reproduction of that. So there are actually on the Airmeet in the resources section, we have a link to that if you want to play with it or see the code. So Solara is open source, MIT license. We do regular releases. We're growing in number of downloads and stars. We have a Discord. There's also a link in the Airmeet. Otherwise, you can join us here. And we had a community hackathon, which we call Solarathon, in combination with Plumer. So we might do this in the future again. So pay attention if you want to learn Solara from us. For adoption, it's also really important that there's some enterprise level support. And just keep this in. I won't talk much about this. So yeah, in summary, I think Solara really simplifies building complex dashboards. It's a modern Python web framework, modern in the sense of also, for instance, the typing, hot reloading. It pushes the boundary of the size of apps or dashboards that you can build. And I think it's really important to enable domain experts to write actually very large complex apps purely in Python. We think it's really low risk because we're using proven technologies. We have an open source community, so there's quite some help you can get, but you can also get professional services. And at last, we want to see less of this grumpy cat and hopefully more of this happy cat. I'll leave you with the resources. There are also resources in the section here on AirMeet, and if there are questions, feel free to
Thank you
ask.
so much for your thank you so much for your talk. I'm Prashant. I'm hosting this. I can see that there are few questions. I will try and show them on stage. So there are questions how Solaris compares to Streamlit, and then there is another question where it says how Solaris compares to TypeI. Um, so
Yeah,
uh, yeah.
I can actually. I think my next slide. Yeah, I have some comparison of Streamlit directly. I don't know how much time. Let me just go through it, and you can read it yourself later on. Also, the slides are there. Generally, the biggest difference is Solara is more towards like large applications, although you can also use it like for smaller applications. Solara has more support for Streamlit, like for callbacks. So you can basically have like interactions with figures. Um, we don't hide CSS. And compared to TypeI, I think TypeI, I don't like writing my UI in a string. What I want is to have a type safety in the whole system, and that is something we had put a lot of effort in a proven system. React is now a technology 10-year old. It has proven itself, and I think it's a much safer bet to reuse a technology that's proven for 10 years instead of coming up with your own DSL in a kind of markdown like string.
Thank you. And there is another question. How is it to style dashboards in Solaris?
Yeah, good question. So yeah, so one thing is it easy? You can style it using CSS, so that's one thing. So it is possible, but styling is always difficult. We usually work with someone that's more experienced in design, but they can fully design. Like the Solara Dev website is fully designed by a designer. That's possible. I can do it myself a little bit as well. I have basic CSS knowledge, and some of the simpler things like colors we expose. But otherwise, we don't try to wrap another layer around CSS. So if you just ask ChatGPT, like, "Hey, how do I do this in CSS?" It should be relatively easy to apply this to Solara.